find this area. We know that the square has the area, the square is 8x everything squared. The side squared. We know exponential rules. When I raise 8x to the second power, what do I get? Anybody, please? 8x.
16, or...
You mean 64?
Yeah, x squared.
Indeed. Can anyone now, let's determine the area of the circle. Remember, is pi r squared. So we have pi, and the r is 4x everything squared. So what do we get? Pi is pi. Exponential rules, we have 4x to the second power.
16x squared.
16x squared. So I will rewrite it as 16 pi x squared. So we have the total area, and we have this area that we have to remove from the total. So how do I represent the shaded area? What should I write for the shaded area, please? How will we determine the shaded area, which is this? We have the total, and we have the element inside. But we only want to determine the shaded area. So what should we do?
(64x squared minus 16 pi x squared).
Very good. From the total area, we subtract the area of the circle. Perfect. So 64x squared minus 16 pi x squared. Sorry. They're also asking us to completely factor this. So we have to start with 64 and 16. What is the common factor to these two? Well, 16 times 4 is 64, so 16 will be the greatest common factor of 64 and 16. Pi is not a common factor, but what else is a common factor? What else is a common factor of these two terms?
X squared.
X squared. Normally, I would have said combine like terms. 64x squared minus 16x squared, but I can't because of this pi. So that's why these are not like terms. The only thing I can do is factor. And I factor out the greatest common factor, which is 16x squared. What is left from the first term? Minus what is left from the second term? What is left from the first?
4 minus 1.
4 minus pi. Very good. Excellent. 16x squared times 4 is this. 16x squared times negative pi is this. This is it. Good. So let's take a look now at 27 and 28.
So what do you put as the answer? You put the 16x squared and then the parentheses?
Yes. Write a polynomial that represents the shaded area in the figure. So then factor the polynomial. Simplify your answer, do not factor. Ah, okay. So here they don't want us to factor in the first step because that's what they put in parentheses. So I will enter 64. I will enter x squared. And then I will enter minus 16 pi x squared. And I'll check the answer, and then oh, because they changed the problem. I'm sorry. They changed the problem on us, so we have to do it again. Because I went to 27, and when I came back, they changed the problem on me.
It's okay. At least you showed us how to put it in. So.
Yes.
Thank
So
you.
sorry about that. Because now the length of this square is 16x instead of what we had 8x, and the radius is 8x instead of what we had was 4x. And then when you click enter, when you click check the answer and it's correct, then you will put the factored form. So here it says do not factor first, and then you will factor.
Okay, thank you.
Sorry about that. Good. This is the same thing. It's just that it's a rectangle and you subtract what's inside. Let me know if we need to do 27 and or 28. Yes, no? 28, maybe?
When it hurt?
Oh, very good. So let's work on 28. So in 28, the same question, use the information in the figure to write the polynomial expression that represents the shaded area. Then factor the expression. So we have a rectangular figure this time, which is 5y by 7y. And we do have two triangles, and the shaded area is all around those triangles. And what do we know about the triangles? I think that this is also x. Would you agree that the base here is x? There are two identical triangles. It's difficult to see, but I think it's x. So, and x and y. Good. So this time, we start exactly in the same way with the previous example. We have to determine the area of the rectangle, which we know is base times height, or length times width. And when we multiply 7y by 5y, can anyone tell us what is the formula for the area of this rectangle? Formula for the area of the rectangle.
35y squared.
Very good. Very good. We multiply the numbers, and then for the variables, we copy the base and add the exponents. Excellent. So we have the total area. Now we have to find the inside of the area of the triangles. So let me refresh your memory with the area of a triangle is base times height divided by 2. And we have x times y. Base is x, height is y, divided by 2. But there are two such triangles. So then the area will be xy. So now the shaded area is exactly like before, the total area, 35y squared, from which we subtract the area of those two triangles. So this is the first thing we need to enter, because they're asking, write the polynomial expression that represents the area and do not factor. Fine. So I will enter 35y squared and then minus xy. And after this, I'm going to ask you, how do we factor? So let's see how we factor. So what is common to these two terms? This is a binomial, and the two terms have a common factor, which is
y.
Yes. So we will have to factor out y. Remember, we started with two terms. I have to have two terms in parentheses. So what do we have left in parentheses?
35y minus x.
So thank you so much. Before you put it in, just multiply and see that you recover that area on the left. Oh, okay. So now here we want to enter y, and we enter parentheses, and we have 35y, 35y minus x. And that is all they want.
Thank you.
My pleasure. This is the same thing, the same thing. Okay. So, see, these problems are not difficult, but they require a lot of time and energy to put in and learn these and get the skill. If you don't get the skill of factoring now, you may have difficulties later. So please make the effort. It's very important. This is huge here. Okay, so let's see what we need to do. Okay, so the x squared, let's practice this. X squared minus 10x plus 24. Okay, so which strategy is this? Which strategy is this? Is it a binomial, is it a trinomial, or is it a polynomial? So let's look at the polynomial again and make a decision. Is it a binomial, trinomial, or polynomial? A binomial will have two terms. The polynomial we're looking at has how many? How many terms?
Trinomial?
Yes, it is a trinomial. Very good. So remember the strategy. Let's go back to the strategy for the trinomial. And here it is. Is it a perfect square? Of course, I have to go through the first steps. Descending order, what is it? I know. Descending order, yes. Greatest common factor, no. Negative leading coefficient, no. So I'm here. First, I have to try the special products. Is this a special product? This is a perfect square, but this is not. So there is no way a special product is applicable here. This is a special product, and this is another special product. They are not applicable here. Then I move on to the next strategy, next possibility, next option. S1 with 1 is the leading coefficient. Is the leading coefficient 1 or any other number? So this or this. Is the leading coefficient 1 or any other number?
One?
Yes. So luckily, it's the easiest of the two. So I will be looking for two numbers whose product is and whose sum is. Anybody remembers?
Negative 12 times 2?
Right, but let's identify them. Correct. Let's identify for everyone to see them. So what do I write? Where does the product come from and where does the sum come from?
X squared minus 12 plus 3x.
So what we need to remember is that this is the product and this is the sum. Notice that you have to take the numbers with a sign in front. You cannot disconnect them. Good. So this is what they're asking us initially. So
-6 and -4?
So they say the two numbers, look for two numbers whose product is 24 and whose sum is -10. So the middle coefficient is always the sum, no matter what. In this case, when the leading coefficient is 1, only when the leading coefficient is 1, then this is the product. If the leading coefficient is not 1, then we need to multiply this number by this number to get the product. But not here, because it's 1. You can say, I always do it. Yes, I agree. 1 times 24 is 24. And the sum is -10. And yes, again, which numbers are we looking at? So here's how we think. Here's the thinking process next. because the product is positive, there are only two possible options. Both numbers are positive or both numbers are negative. But since their sum is negative, numbers cannot be positive. Because when I add two positive numbers, I cannot get a negative number. So they both have to be negative. So that's the thinking process. After I identify the product and the sum, I have to look at the sign of the product. That's the next thing. The product is positive. Therefore, the two numbers have to have the same sign. And the sum will tell me which of these two signs. And never positive, because when I add two positives, I will not get a negative number. Good. So then, which numbers are we looking for? Again, sorry, Rachel, if you want to say it again.
-6, -4.
-6 and -4. Why? -6 minus 4 is -10. -6 times -4 is positive 24. So therefore, from here, can anyone give us the factored form? What is the factored form here, please? Can anyone give us the factored form?
X minus 6, X minus 4.
Indeed. Remember, it takes 5 seconds to verify this. Very simple. X squared, negative 4x minus 6x, -6 times -4. Any questions? Is this okay? Is this okay so far, please? Anybody? Anybody? Okay, let's move on then. Good, back to the assignment. Let's see what else is in here. Perfect. Good. Okay, what does it want? Fine. Good. Same thing. Okay. Okay, just factoring. We're gonna look at problems in a second. Without the help, this is a little bit easier because the help is there. Regardless, if you want me to stop on any problem, please say so. Okay, so here is the first one that we want to work on. X squared plus 9x plus 18. First, we have to identify the type of polynomial. What type is it? Is it binomial, trinomial, or polynomial? Without identifying the polynomial correctly, we don't know which strategy to apply. Polynomial, binomial, or trinomial?
Trinomial?
Yes. It has 3 terms, so it's a trinomial. Excellent. Descending order, no greatest common factor, no negative leading coefficient. A special product is not applicable because this is not a perfect square. Is
X
1
plus 6, X plus 3.
perfect? Is 1 the leading coefficient? Yes. So we are looking to find two numbers whose product is 18 and whose sum is 9. Oops. Indeed, and 6 and 3. So the product is positive, both have to have the same sign. Since the sum is positive, both have to be positive. So can anyone then give us directly the factored form?
X plus 6, X plus 3.
That's it. It doesn't matter if you write it x plus 3 times x plus 6. We know multiplication is commutative and associative. It takes 5 seconds to verify. Don't enter it and say, oh, I think it's this. No, no, no. It takes 5 seconds to verify. X squared, positive 3x plus 6x, 6 times 3. That's why this is the sum. Remember what I said? 3x plus 6x, this is the sum. And 6 times 3, this is the product of the same numbers. Good. Same. Same. Actually, let's look at 12. Any questions?